Hello students, we are going to learn today the graphical method of solutions. It required 4 steps. Represent the data problem in a mathematical form. Step number 2, draw x and y axis in the first quadrant. Plot all the constraints on the graph, which we are going to get it out of the mathematical problems. Then identify the feasible region. That is, we are going to draw area above the greater than away from the origin, that is 0 0, and we are going to draw or shade for all the equations which are less than or equals to, which are towards the origin 0 0. Let's take an example. The example looks like this. A book house produces two kinds of books with profit of rupees 5 rupees and 3 rupees respectively. They produce two types of books, type 1 and type 2. Each book need two processes, print and bind. Type 1 book need 3 hours to print and 5 hours to bind, while type 2 book need 5 hours for print and 2 hours of bind. Book house have maximum of 15 hours for printing and 10 hours of binding the book. Now we need to find it out how exactly we can give the maximum profit to this particular book house. Let's get into the first step of this, that is we need to set it as a mathematical equation. So let us represent it. This is how exactly it looks like. We had a maximization problem. Mathematically this can be shown as maximization of Z, that is 5 rupees on the type 1 book and 3 rupees on type 2 book. So we can say that maximum Z is equals to 5x plus 3y, where we had two constraints. It is having a very first one is a printing constraint, that is 3 hours needed for the type 1 and 5 hours needed for binding for the type 1 book. And type 2 book we have 5 hours for printing and 2 hours for binding. So it will going to give me two equations where we assume that x and y will going to be greater than 0. Let us solve them, those particular equations. The solution looks like this. If I take x is equals to 0, let x equals to 0, then we get y is equals to 3. If I take or assume y is equals to 0, then we get x is equals to 5. Look at the equation number 1. Equation number talks about 3x plus 5y is less than or equals to 15. So it is going to give us a solution of the two coordinates 0, 3 and 5, 0. Now let us solve equation number 2. Equation number 2 looks like this. We have a 5x plus 2y plus is less than or equals to 10. So if I assume x is equals to 0, then we are going to get 2y is less than or equals to 10. It will going to give me y is equals to 5. Similarly, if I assume y is equals to 0, then we get x is reduced to 2. So we get two more equations, though the constraints are reduced to the equations like 0, 3, 5, 0, 0, 5 and 2, 0. Now it's the time to represent that on the first quadrant of the graph. The first quadrant of the graph we need to represent 0, 3, 5, 0 and 0, 5 and 2, 0. First coordinate is x and y, second coordinate is y. Now you can see that I had drawn those lines already. You can see that this is the first equation which talks about the 0, 3 and 5, 0, which is represented as the equation number 1, and the second equation is drawn over here, that is 0 and 5 over here, and 2 is x coordinate and y coordinate is 0. So we got two coordinates now. Now I said like we need to find it out the equation which is going to be feasible region. So the feasible region looks like it is shaded now. It is both the equations are less than, so it is drawn towards the origin. So it will going to give me the four coordinates a b c d. A b c d talks about, I'll just change it, a b c d. So we are going to draw a b c d equations over here. A is 0 0 as starts from. B is going to give me the equation 0, 3, x is 0, y is 3. C is 0.8. You can see that 0.8 and 2.8. It is almost 2.8 here, and x is equals to 2.8, y is equals to 2.8. Then D is 2 and x is 0. So we got 4 difficult equations. From here I'm going to draw the conclusion. So we can have a z, maximize z is equals to, equation given is 5x plus 3y equals to 0. So which will going to give me the solutions. If I put first equation at a, it is 0 0, so I'm going to get a z equals to 0. If I take coordinates for b, that is 0 and 3, so I'm going to put 3 into 3, that is 3 into y, so I'm going to get a 9 as a value. At c I'm going to get 5 into 0 0.8 plus 3 into 2.8 will going to give me 12.4, and at d we are going to get z equals to 5 into 2 is 10. So we have the 4 values here at different coordinates: 0, 9, 12.4 and 10. Among these, 12.4 is maximum, so we can say like the best solution for this particular book house problem is 12.4, which is in the decimal places. If I round it off, it will going to be 0.8 can be rounded to 1 and 2.8 can be rounded to 3. So I can say that book house need to produce 1 unit of type 1 book and 3 units of type 2 book to get a maximum profit. If any queries are there, please revert back to me. Thank you very much.